Hey everybody. In this video, we're just going to do this warm-up problem, which is going to introduce us to the idea of counting principles and sample space. So here we have Linda has 5 shirts, 3 pairs of pants, and 3 pairs of shoes. How many different shirt, pant, shoe outfits can Linda make? So first we have to assume that each shirt, pair of pants, and shoes would all match each other, because otherwise why are we even doing this? But if we think about what Linda has, if Linda has 5 shirts, for each shirt that she chooses, she could use 3 pairs of pants with each shirt. Oop, that should be a P. And so on and so forth. And for each shirt and pant combination, there's also a pair of shoes. I'm just going to put F for foot. So she's got shoes 1, 2, and 3. Now, how do I get how many pairs of pants could go along with the shirts? How many different combinations so far? Well, we take the number of shirts and we multiply it by each shirt has 3 combinations. So for each shirt, you multiply by 3, and that's the number of combinations. And then for each shirt and pants, we have another 3 combinations, so we multiply by 3 again. We basically take these numbers and we multiply them together. And so the number of shirt, pant, shoe combinations that Linda has is going to be 5 times 3, which is 5 times 9, which is 45. So there are 45 outfits that Linda can use. Okay. So now let's talk about the second example. How many different ways are there for a couple to have 3 children in terms of gender when born? So what we're going to find out here is that we can list out the sample space. So the sample space is all the possible ways this could go down. So what could happen is this couple could have 3 males at birth. They could have a male, a female, and another male. They could have a male, a female, a female. They could have a male, and a female. And I am counting this value and this value as 2 separate ones, 2 boys and a girl. The order still matters because the middle child is a girl and a female in this one, and then the youngest child is female in the second example. And so the order matters. Those are 2 different scenarios. Now we could also have 3 females at birth. We could have a female, male, female. We could have female, male, male. We could have female, female, male. And so those are all 8 possibilities we can have if a couple decided to have 3 children, and these are the genders at birth, assigned at birth. And so there are 8. Now, if we have 4 kids, same example, but with 4 children, this all of a sudden becomes a lot more to list out. And maybe I don't want to list it out. So is there a fast way to get the number of values that are in this sample space without actually having to list it all out? And there is. So if we think about assuming that there's only 2 genders that will be assigned at birth, male and female, when the first child is born, there are 2 options for that child. They are either assigned male or female. And then for the second child, so that's the first child, for the second child, they are either assigned male or female. And for the third child, they are either assigned male or female. And so if I multiply these together, sort of like the outfit in the Linda example here, the shirt, pants, and shoes, what we end up with is 2 times 2 times 2, which gives me 8 possibilities. And with 8 possibilities, that matches up with the sample space that we have here. So again, this is the sample space because it's a list of all of the possibilities. And the sample space is going to become important later on when we have more difficult problems that we can't necessarily think of off the top of our heads. And so we'll revisit this sample space later on in an example. But for now, that's all there is for this video. I'll see you in the next one.